Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. So let's look at question 9, cubic function. How beautiful. So let's see what you have. The graph of f of x is equal to ax cubed plus bx squared plus cx minus 5 is drawn. Sorry, below is drawn again. Then E with coordinates -1 and 0 and G with coordinates 5 and 0 are the x-intercept of f. Okay. You can see x-intercept like that. And then we now know the y-intercept. Remember this one, the constant here, it is the y-intercept. So it means the y-intercept here, it is -5. Okay. Remember, if I were to let x is equal to 0, it's going to be 0 this one, 0 this one, 0 this one, and -5. So it is the y-intercept. Show that a is equal to 1, b is equal to -3, and c is equal to -9. So basically they are saying determine the equation of the thing. How can I determine the equation of the thing? What is it that I'm given? I'm given the x-intercept, right? But remember, this is what I say. If now I'm having a graph like this, can you see I have one x-intercept and another x-intercept, but that other x-intercept, it is acting as an x-intercept. It is also acting as a what? As a turning point. So it tells me that somewhere, somehow, my graph has a what? Has a what? An equation or factors that are like this. So one of the factors, it is repeating itself twice. Okay. So how can I find that? Can we find the equation of of this graph, of this function? Yes. Remember, if I'm having the x-intercept, I'm gonna use the one with the x-intercept that says y is gonna be equal to a into x minus x1, x minus x2. I could have added x minus x3, but now can you see that there are only two x-intercept, but this one, it is repeating itself twice. Why? Because it is acting as a turning point as well as the x-intercept. So I'm going to just allow one to be squared. Again, yes. So I'm going to say, I'm going to just need any point for y and x. Any point, it is this point, which is x is equal to 0 and y is equal to -5. So I'm going to say y is equal to -5. A, what is x? X, it is just 0. Okay. Let me say use point 0 and -5 for x and y, not x1, for x and y. So y is equal to -5. A, x it is 0 minus what is x1? X1, for this one, I'm going to choose x1 as 5. Why? Because the squared is for the 1. Okay, let me do this. I can rewrite it like this. Still fine. What is x1? X1, it is this one. Why? How do I know if it is this one or this one? Because since when it is unlike the one with the 3 x-intercept where I can choose anywhere. This one, you should be careful. The one with the squared, it means it is acting as a turning point as well as the point of turning point as well as x-intercept. So which one is that? It is this one. Can you see? This one is just only the turning point. This one is just the x-intercept, but this one is just the x-intercept as well as the turning point. So hence I have the squared. And then minus what? -1. When I minus -1, it's just the same as adding 1 squared. And then I have 0 minus 5. Minus 5. And then I have -5, it is equal to a multiplied by 1 squared, it is 1, multiplied by -5, it is -5a, and then I get a, it is equal to what? 1. After doing that, I can go back to my equation and say, okay, I'm going to go back to my equation and say, oh, y it is equal to x, it is 1 into x minus, I already know the x1. X1, it is this one, okay? So it is -1, so it will just be plus 1 squared and then x minus 5. Am I done? No. I need to simplify this a little bit further. How can I simplify this? It's just going to be y into, this is just 1. I can just simplify this. When you simplify this, it's going to be x squared plus 2x plus 1 multiplied by x minus 5. And then I have y is equal to x multiplied by x it is x cubed, x multiplied by, okay, let me start with x squared multiplied by x, it is x cubed, x squared, okay, 2x multiplied by x, it is plus 2x squared, then 1 multiplied by x, it is plus x. And then let me move on to negative 5. Negative 5 multiplied by x squared, negative 5x squared, 2x multiplied by negative 5, negative 10x, 1 multiplied by negative 5, negative 5. And then y is equal to x cubed, 2x squared minus 5x squared, it is negative 3x squared, x minus 10, which is 1 minus 9, 10, it is negative 9x minus 5. So can you see that A, B, and C are proven? So you just say, yeah, you are done because you have already proven that A is equal to that and that and that. So you have already shown that. You can conclude by saying A it is equal to 1, B is equal to negative 3, C is equal to negative 9. Then you'll be sharp. I won't erase the equation. I'm going to need it later, I know. I'm going to need the equation later on. So for now, let me just remove these for now. Okay, yes. Okay, so they ask me 9.2, they say to me, 9.2, calculate the values. Okay, not the values. Calculate the value of x for which f has a local minimum value. So calculate the x value for which f has a local minimum value. So local minimum value, this is what? Local maxima, local minima. So they want the x coordinate of this one. Okay, so they want the x coordinate of this one. How can I find the x coordinate of this one? Local minimum. Local minimum, it is the turning point. Okay? Local maximum and local minimum, it is the turning point. So how can I find the x coordinate of the turning point? Remember at the turning point, the gradient, which is the derivative, it is equal to what? 0. Also here, the gradient, but we already know here the value of x, it is negative 1. So, but still, the principle applies. So now let's get the derivative. They want only the x value, okay? Only the x value. Here we already know the coordinate, it is negative 1 and 0. Here the coordinate is 0 and 5. No, not 5, negative 5. So we know that when we let our derivative be equal to 0, we're going to get one of the factors as negative 1, and then the other factor is going to be here. It should be positive. I think I'm assuming it should be positive 3, looking at the sketch, but I don't know. Let's see. We'll see. But close to positive 3. So how can I get that? I need to derive. Remember, for my turning point or local minima and maxima, I need my derivative to be equal to 0. What is my derivative? What is my function first? My function, it is like that. So my derivative should be 3x squared minus 3 times 2, it is 6x, minus 9, it is equal to 0. And then I can take out a common factor and say it is x squared minus 2x minus 3, it is equal to 0. And then the factors of 3 is such that when I subtract them, it is equal to 2, 3 and 1. 3 minus 1, it is 2, but I want negative 2. So it is really, it will be negative 3. And then negative 3 minus 1, it is negative 4. When this I make this positive, it's going to be negative 3 plus 2, it is negative 2. So it's going to be given the middle term. But you like to say the factors are 3 and 1, and then the bigger sign takes the sign of a middle term. The bigger term takes the sign of a middle term, which is negative 3. X minus 3, x plus 1 is equal to 3. Then can you see that x it is equal to 3 or x it is equal to negative 1? But now the question was, calculate the x coordinate for the local minima. So for the local minima, it is this one. Minimum and what? Maximum. So for the local minima, we already know the x, it is negative 1. Right? So we'll just say, therefore, when you conclude thereof, you'll just say, therefore, x of local minima, it is equal to 3. You can just conclude. Okay, yes. So now that we know that this coordinate here It's not straight. As we know that this coordinate here, it is 3. Or let me put it 3 here. 3 and whatever x coordinate. So at this point here, I have 3 and whatever y coordinate. Good. We are cruising nicely, guys. Use your graph to determine where the second derivative multiplied by the function is greater than 0. What do they mean by that? Remember, they mean when I multiply the second derivative multiplied by f, which will be greater than 0. Meaning, when I multiply positive by positive, it's going to give me a positive. Remember, greater than 0 means the outcome should be positive, or multiply negative by negative. Okay? So, first thing first that I need to do, I need to draw my what? I need to draw my this graph of second derivative. How can I draw that graph? I need let's check the point of inflection first, guys. Point of inflection, it is a point between what? Between the two turning points, right? So how can I get the point of inflection? I'll just say it is -1 plus 3 divided by 2. So it will just be -1 here, guys. And whatever value of y. Now, guys, before I don't want to waste time on this question, I'll show you this. When I derive, okay, I want to show you this. And please go to and look at my video where I explain this. When I derive my, I'm going to talk about the x coordinate field. Let's say this is the point of inflection somewhere here. Guys, when I derive my cubic function, which is f, when I derive it, the x coordinate of my turning point are going to be equal to my x-intercept. So this coordinate here of A, x coordinate of A and the x coordinate of B are going to be my x-intercept. And the point of inflection is going to be my turning point. Okay, so basically it means now when I derive my cubic function, the x coordinate of my turning point are going to be the what? The x-intercept of my parabola. And then the x coordinate of my, when I derive my cubic function, the x coordinate of my point of inflection is going to be the x coordinate of the turning point. And now how do I know the shape of the parabola? I check the last shape of this one. It is hip. So it means this one should also be hip. So it means I'm expecting a graph like this. I get. And then my x-intercept at A and B. And then this is C. Okay? And then the question is, what will happen if I were to derive? What will happen if I were to derive? Remember, this is F, this is F prime. If I were to get F prime prime, what will happen? When I derive my parabola, the x coordinate of the turning point become my x-intercept. Always when you derive a parabola, the x coordinate of the turning point become the x-intercept of the what? Of the straight line. And then these ones I do not care. Remember, for I only need one. So it's gonna be like this. Can you see, guys? So it's basically this. So this is just my x. So can you see that it means now the second derivative shares the common x coordinate with the what? With f, which is what? The point of inflection. Can you see? Can you see where C started? C started from point of inflection to turning point to x-intercept. So it means now the point of inflection of f, it is the turning point of C, also the x-intercept of what? Of the straight line. I repeat, the x coordinate of the point of inflection of the cubic function, it is the x coordinate of the turning point of the parabola, and it is also the x-intercept of the straight line. So it means here, if this is my point of inflection here, Remember, if this is f, I want f prime prime, and I know f prime prime is going to be my straight line. So it's going to be something like this here. So it's going to be x is equal to 1 here. So it means my graph is going to cut at -1 here. How is this -1, guys? At 1 there. At 1 there. But now the question is, what is the y value of that one? I mean, you can get it easily by saying, if this is f of x already, how can I get f prime prime? F prime prime is going to be, I want to show you, it's going to be just 6x minus 6 is equal to, then equate it to 0. It's going to be 6x is equal to 6, and then x is equal to 1. Can you see I was honest? Can you see I was telling the truth here? It is 1, the x-intercept of the straight line. But now what about the y? I take the x and then I put it to where? The question is, I put it to, oh, okay, never mind. I want the y-intercept. For y-intercept, I let x equal to 0. Okay? For y-intercept, remember, okay, let me say this is going to be 6x minus 6 is equal to 0. This is when I want the what? The x-intercept. I let the y equal to 0. But for y, which is now x is equal to 1. But for y-intercept, I need to let x equal to 0, which is now y is equal to -6. So it's going to cut at -6 here. So this is, I'm going to have a straight line like this. Okay. When I have a straight line like this, boom. What's happening, Kanti? Okay. So this is the graph of f prime prime, guys. And the coordinate here, it is 1. Okay. So now we want what? I think this one I've explained is fine. We want what? We want where, I'll write it here. We want where second derivative multiplied by f is greater than 0. So we want where f prime prime it is positive and multiply by positive so that it becomes positive. Remember, greater than 0 is positive. Or where f prime prime is negative and then this is negative, it gives us positive. So let's start with the first outcome, positive, positive. Let's check where f prime prime is positive. F prime prime is positive here. And where is f positive? F is positive here. So guys, do you agree with me that this is going to continue like this and f and f prime prime is going to continue like that? I want this to make sense to you guys. Okay? Yeah. Okay. Now, so we're going to say, okay, it's positive here, also here, also here, also here. Talking about f, and then f prime prime is positive also there, also there. And then other way, they are negative. So where are they both positive at the same time? Can you see that from this point here? If I say 1, can you see that this one is negative, this one is negative? Okay, I'll also say negative. F is negative, so that you get a sense of this. Also, F is negative here. So can you see that where they are both positive, it is from 5 going to that side. It is this portion. Can you see where they are both positive at the same time? So the first solution it is when x is greater than 5. Okay, because they just said greater than 0. So the first solution for this one, it is when x is between what? 5 and what? And positive infinity. Can you see it's going to continue there? Or someone might say x is greater than 5. Okay? Let's now look at the negatives, where they are both negative at the same time. Where are they both negative at the same time? Can you see in this portion from negative infinity here? And we go, okay, let me do this. We go, they are both negative, until we reach 1. Until we reach what? 1. Until we reach what? 1. After 1, can you see that it is positive and negative? So we do not want that. So it means now the other solution is going to be, you're going to say when x is between what? Negative infinity. Can you see? Started from negative infinity to where? To 1. To 1. I'm not including it. Or someone might say when x is less than 1, from 1 going to that side. Okay, so yeah, these are the two solutions. These are the two solutions. So the first one, I'm going to say x is an element of negative infinity to 1, or x is an element from 5 to infinity, guys. So this will be 2 marks. Why? Because you found the what? This value of x. It was not given, but this one is just 1 mark because you were given it. Okay, guys, these questions are not difficult. What if they said, let's have our own question where they said f prime prime multiplied by f is less than 0. And let's put equal. Okay, let's put equal. So how can you answer this? We want to where this one is positive, negative, or negative, positive, because the outcome is going to be negative. So let's first test the first condition. Where is f prime prime positive and f prime f negative? F prime prime is positive here, and this one is negative here. So where are they alternating positive and negative at the same time? So it is on this portion. So it is between 1 and 5. So between 1 and 5, can you see here? Positive and negative. And then here it stops at 5. So can you see positive and negative? So we're going to say when x is between, I'm going to include it. Why? Because it has an equal sign. 1 and 5. Or another solution, if it's there and it's possible, where is f prime prime negative? F prime prime negative, I want to remove this one. Okay. F prime prime negative here, and f positive here. Can you see that this combination will not happen? It will not happen. This combination will not happen. So we only have one condition. Sorry, not condition. Condition thereof. So it's going to be between 1 and 5 included, like that, guys. Can you see? Beautiful. Beautiful. Allow me to erase these, guys, because I need to move on with the questions. The last one. Okay, hopefully it made sense, guys. Hopefully it made sense, guys. Okay. And then they said using the graph, guys. Using the graph. Use the graph. So don't try to become a mathematician and solve, guys. We know that you are good at mathematics and solving algebra, but don't do that. It's going to be a mess. So the last question that is very interesting for students, it says, for which values of t will the graph of p of x, which is equal to f of t, have 2 distinct positive roots and 1 negative root? So distinct means different positive roots, guys. So how can we get this graph of ours to have what? 2 positive roots and 1 negative root. And can you see the t is positive? So it either is going to move down or up. So now, if it is, our graph needs to be moved up, then it's fine, this t. But if it needs to be moved down, we change it to negative t. We change it to negative t. So let's see, guys. Let's try to see that. Okay, let me try to redraw this graph. It's going to be that graph. Let me repeat that. Man. Let me repeat that, guys. Sorry for being a mess, guys. Yeah, hi. Now let's see. Let's see. Here's my graph, right? If I move it downwards, okay, now can you see that for now, it has what? It has one negative root and one positive root. And now what do we want? We want two, uh, two positive roots and one negative root. Let me use a different color so that it's going to be clear. I'll explain this thoroughly, guys. You'll understand this. It's fine. Don't worry. And then, thank you. Having one negative root and one, guys, roots are just x-intercepts, guys. Roots are just x-intercepts. Okay, roots are just x-intercepts. So the first one, it is negative, the first one is positive. So how can I shift this graph such that we'll have positive, two positive and one negative? Remember the coordinate here. The coordinate here, it is -5. The coordinate here, the y coordinate here. Guys, I need the y coordinate here. I will need the y coordinate here. It's going to be very, very important for me. The y coordinate here, it is 0, it's fine. It's 0, it's fine. And then I'm going to need the y coordinate here. How will I get that? Remember my graph equation, it is y is equal to 3x, not 3, I'm lying. X cubed minus 3x squared minus 9x minus 5. So here, remember the x coordinate, it is 3. So I want to see at 3, how much is my y? So I'm going to say 3 cubed minus 3 into 3 squared minus 9 into 3 minus 5. I want to quickly get that answer, guys. I'm going to need it. It's going to be -3. Okay, I'm lying. 3 cubed minus 3 into 3 squared minus 9 into 3 minus 5. We get -32. Okay, so now I want you to see this, guys. Let me erase this. Erase. When I erase that, guys, let's check. When this graph now, if I were to move this graph downwards like that, can you see what's going to happen? When I move downwards, this graph is going to move downwards. Okay, when I move it downwards, it's going to only have what? It's going to only have one positive root, right? And that's not what I want. So let us try to move it upwards instead. When I move it upwards, I move. Okay, I move and reaches this point. When it reaches this point, it has moved 5 units up because this was -5 and now it is now 0 here. So when it has moved 5 units upwards, guys, 5 units upwards, it means now I'm now having how many roots? Can you see this is one negative root and one positive root. Remember, this one is not positive or negative. It's just like this. Okay, this one, it is 0. It is not positive or negative. So I'm having one negative and one positive. Oh, okay. Let me try to move upwards again. Can you see I moved 5 units upwards, right? Let me try to move further 5 units, another unit upward. Can you see, guys, when I move another unit upwards, can you see what happens? When I move another unit upwards, can you see what I'm getting? I'm getting negative root and 2 positive roots. Okay, so it means I need to move more than 5 units. Because when I moved exactly 5 units, do you agree that my graph was somewhere here? My graph was somewhere there. When I moved, well, my graph was somewhere there. But now when I moved a further 5 units upwards, can you see when I moved a further 5 units upwards, which is somewhere here, can you see I'm having negative and 2 positive roots? But now, okay, so it means the first one that I need to take note of is that I need to move more than 5 units, okay, upwards. More than 5 units upward. But where should I stop? Where should I stop? Because I can't continue forever like this. Can you see? If I wanted to continue forever like this, can you see that I'm going to have what? No, actually one root because this one extends. I was going to have only one root because this one extends like that. So I was going to have just only one root. But where should I stop? Let me return back my graph. Where should I stop? I should stop where? Let's check. Let's continue. When I continue with my graph going upwards, going upwards, going upwards, going upwards, going upwards, going upwards, going upwards like that, I'm still having, let me take track of you, I'm still having negative and 2 positive. But can you see now they are narrowing? Let's go upwards. When I go upwards, go upwards, go upwards, go upwards, go upwards, until this point here reaches there. Remember, this one is going to continue like that. So this is just negative one root, one negative root, and one positive root. Can you see it is now one positive root? Okay, so if it is exactly from this point to here, 32 units points, 32 units upwards. So can you see when I move 32 units upwards, it is going to give me two, okay, one negative root and one positive root. So how about I go a little bit downwards again? When I go a little bit downwards than 32, this is no longer 32 units. So we might, let's say this is 31 units upwards. Can you see? The reason I'm saying it was 32, it is because when white is now 0, it tells you that it moved 32 units up. But now in this case, it is a little bit further. So it's still having what? 2 positive and 1 negative. So it tells me that I shouldn't move more than 32 units because when I move more than 32 units, I'm gonna go back to negative, 1 negative root and 1 positive root. So I am realizing that I should move more than 5 units up, but not more than 32 units up. So it means I should move more than 5 units up so that, can you see, did you agree that for me to move 5 units up, it ended up being something like this? Let me redraw that graph. It was something like this. It was something like this. When I moved it exactly 5 units upward, it had what? It had it had one negative and one positive. Okay, when it was exactly 5 units upwards, exactly 5 units. But now when I moved it further than five, further than five, further than 5 units, further than 5 units, it started having negative and 2 positives. So it means now I should move more than 5. But should I move more than 32? No, check. When I move more than 32, check. It gives me 1 negative, 1 positive. So it means I should be below nyana what? 32. Okay? So I should be between this boundary thereof. I should be between this boundary thereof. Not more than that. But what is that boundary? That boundary is that I moved more than 5 units up, but less than 32 units up. I hope that's clear, guys. So when we put that in terms of a beautiful answer, in terms of a beautiful answer thereof, we're gonna say t, the value of t should be greater than 5. So 5 should be less than t. It means t should be greater than 5. But t should also be less than what? Less than 32. So it should be negative, guys. Okay, so t should be greater than negative 5, should be moved upwards like that, and then it should be moved 32 units upwards, guys. We agree. I believe that we agree, guys. I believe that we agree. If you do not agree, I don't know, guys. Leave it in the comment section and tell me what you think. I don't know. I think this one is the best solution. Okay, not negative, guys. So not a negative 5 and positive 5, a negative 32. Remember, I said it needs to move upwards by 5 and upwards by 32, not more than those. Okay, yes. Yes, guys. So sorry about that. It's just 5 units upwards and not more than 5 units upwards, but not more than 32 upwards. So it should be between these two boundaries thereof. Okay. Yes. And another thing happened. Let me see. That you can do instead of doing this. What you can do, you can use your ruler. Okay. You can use your ruler. This is another step. How can I use my ruler? Start here. When I'm here, how many roots do I have? Can you see? It is here. It is only one negative root and one positive root. So I don't want that. When I continue moving upwards, guys, continue moving upwards. Let me cut here. Continue moving upwards. Can you see it is one negative and two positive? Okay. Let me continue moving up. Let me go back here. Remember here, I just said it is only 1 and 1. And let me move upwards again, guys, and reach here maybe. Let me reach here. When I reach here, guys, remember the y value here, it is negative 32. When I reach here, it's still negative, 2 positives. And then when I reach this point, what happens? Let me check. Exactly at the y-intercept. I want to see what happens exactly at the y-intercept. Exactly at the y-intercept, I'm having 1 negative, and this is not negative or positive. It's just 0. So I'll leave it, and then, can you see now? Okay, let me move a little bit up further again. So to cut it here, it's just going to be 1 negative and 2 positive. So I want where the boundary where now, it is now between what? The boundary between where they have 3. So can you see they have 3 when you start moving upwards? Okay, when you start moving upwards, here it is 3, having 3, having 3, before it can reach what? Where x is equal to negative 5 here. So it is just between these two values here. Okay, it is just between these here. So it is between what? So I'm going to say t, it is between what? The two boundaries, negative 32 and 5. But now it moved upwards. It moved upwards. So we moved upwards 32 units, okay? But not more than 32 units. And I also moved upwards 5 units. So it is between these two. But when it has moved upwards, it's going to be positive, positive. When it moved downwards, we're going to say negative, negative, guys. Can you see that? Yes, so that's basically that. So without wasting any further time, I think I'm done, guys. Hopefully you understood how we can do this question. I like this one of shifting a graph so that it makes an actual sense. How do you make a graph that moves in an exam? Just ask yourself, just move it with your hands and see, or you can use a pencil and say, okay, what if it is here? Just use your pencil and okay, let me move a little bit up again, like something like that. Okay, so yeah, thank you guys for being with me again. in this video. Hopefully you enjoyed. And yeah, if you did, well, that's good. Let's move on to the next one then. A sharp.